microsievert per hour, and we have summarized here the results for 4 measuring points until 16th of March. And you can see we had a slight peak of 0.120 millisievert per hour at the beginning of the 16th of March, and it is immediately decreasing now. I gave you here one figure for the comparison. 0.05 microsievert per hour is the background level before the earthquake and the tsunami happened. Now I will come to the offsite situation. As it was mentioned by Mr. Andrew, we get now since 2 days information from 47 cities in Japan. These are I would say regularly, nearly every hour, and we started to evaluate these levels, and I will provide you I have selected 3 major cities here in 100 kilometer distance, around 100 kilometer distance to cities, and I took Tokyo for your information because Tokyo has quite a high population, quite a high number of inhabitants. So let's go ahead. We have, and in the first slide, you can see the dose rate at Ibaragi, which is 120 kilometers southwest from the nuclear power plant, Fukushima. And you see that we had at the 15th of March a peak with 1.5 microsievert around, and we had at the 16th of March around 1 microsievert per hour. Maybe you can't see it very good here. Here is a line of the background. So you have peaks, but if you consider a dose rate, you have also, if you consider an exposure, you have to consider the length of an exposure. This is a very important topic. So parameter. In general, I can say that these dose rates doesn't mean any health effects. In the second city, again 150 kilometers southwest from the Fukushima nuclear power plant, we see here also the peak in the same size or order of magnitude of 1.3 microsievert per hour, and we have then a decreasing level to a number which is a factor 2 around above the background level. And the third city is Tokyo, which I would like to show you here. And please, I should have taken the same axis here. We speak here in Tokyo about an increase of the dose rate at the 15th of March to 0.5 microsievert per hour. Please let me say that in Tokyo we have a range of the natural background which is between 0.003 and 0.1 microsievert per hour. This is the situation until the 16th and 17th of March. We have now got some more information on dose rates in the surrounding of the nuclear power plant. That means 20 and 30 kilometers and above. And a group in the IEA Secretariat starts to assess that doses continuously. Thank you for your attention.
So the usual, please. Just a question to Mr. Andrew, and then he will redirect the question if necessary. George?
George John, Associated Press. Graham, it was all very interesting, but it would be nice for physics dropouts like me if you could kind of compress pressure, water levels from last week through the worst periods to the situation now. Have water levels at at the affected sites gone up measurably, moving towards normal levels? Has pressure stabilized? Is it moving towards normal levels? I know we're not there yet, but just like a general picture of.
Well, I think I characterize it as moving to a stable, in other words, non-changing situation. That's positive in that what you don't want is something that is rapidly changing. It's true that, in rough terms, perhaps half of the fuel in some cases is uncovered, which is not positive. We want all of the fuel to be covered. But it's not oscillating, it's not going down dramatically. So, as I said in my introductory remarks, that certainly for the units 1, 2 and 3, the situation, taking on board the pressure and the water levels, remains fairly stable, which is positive.
Thanks. Matthew?
Hi, Matthew Chance from CNN. Can I ask you to detail what the reasons were for the raising of the accident level in Fukushima from 4 to 5? And could I also ask you to perhaps explain what the wider consequences might be of this disaster, now that we know that it does in fact have wider consequences than were previously stated?
Right. Thank you, Matthew. I think first thing I should say is that the revised ratings are not ones which the IAEA have made. These are coming from Japan, and there will be, I'm sure, after the emergency is over, a great deal of attention placed on were the ratings exactly right or wrong. But in a way, that's not the most important issue of today. The important issue of today is to get water into these reactors. But perhaps I could ask colleague Denis Flory to add some further comments about the Innes scale and the changes that have been made. Yeah.
Yes, thank you. Well, first, I think, again, it is important to remember that this is a scale for communication. This is not a scale for assessing and working, for the teams working on assessing the situation. It is really for communication. There are some principles, there are guides. I may have already shown that, but this is the user's manual for the Innes scale. And then there are, in fact, 3 sets of criteria to determine level in the Innes scale. One is about the releases to people and environment. Then there is another one which is about the radiological barriers and the control of the facility. And there is a third one, which is about defense in depth, which may be activated, you can say, even with, if there has not been an accident. In the case of the Fukushima Daiichi reactors 1, 2, and 3, the Japanese have said that they have operated because of core damage. So this is, they have assessed that there has been some core damage, which then it is related to damage to radiological barriers and controls I mean, this is the second set of criteria which I mentioned. Visually, you have here the criteria about people and the environment. Here, the criteria about radiological barriers and control. And here, defense in depth. And you can see here that it's only with the criteria about people and the environment, it, in short, releases or irradiation of people that can go up to level 7. As concerns radiological barriers, these criteria can lead up only to level 5. So for reactors 1, 2 and 3 of Fukushima Daiichi, the level was raised from 4 to 5 because of the assessment by the Japanese government of damage to the core, of some damage to the core. We don't know how much, what is their assessment. As concerns the fuel pool of Daiichi 4, the rating is only, again, it is, no, it seems to be linked, well, it is linked to a loss of defense in depth, loss of cooling of the fuel pool. And as concerns also Fukushima Daini, it is again linked to the loss of cooling. So it is not a criteria which is linked to radiological releases. In short, they have not assessed at this stage what would radiological releases mean in terms of INES scale. This will take time. Also, as concerns damage to the core, I think I've already said that, but I can say it again. If we take the accident of 3 Mile Island, it took 5 years to assess the damage to the core. So this is the situation as seen by the Japanese authorities today. This will certainly be subject to review by the Japanese authorities, and it is a subject which may also come during the next review conference on the Convention on Nuclear Safety, which will be here in Vienna beginning of April, where all states parties to this Convention on Nuclear Safety gather together and exchange the reports on the status of safety in their country with questions and comments from other parties to this convention. So this is, again, an evolving process, and the ultimate rating will not be known before weeks, months, possibly years. But again, the importance it is for the Japanese authorities to get to a more safer situation, in one word, to cool down as much as they can reactors, fuel pools.
Jonathan?
Jonathan Tyrone with Bloomberg. Continuing with the pool at Unit 4, the spent fuel pond, are we aware how close emergency response workers have been able to come to that pool at this point? And along with that question, given the plutonium inside of those fuel rods and the likely state of the neutron absorption units, is there any assessed risk of a criticality event when water is introduced to those, or to that pond?
Well, perhaps I could just some initial comments. I think criticality is an issue, providing the spent fuel geometry has not changed, because Of course, prior to the accident, there was water around them and providing their